Okay, let's hope this works out because the last couple of attempts did not have audio. So we want to learn how to export our data and to create the data cube. So the file I'm using is run team saipan flow run cylinder shorten trim 200 time steps. And this file contains 200 folders. I don't know if time steps is the right word, but there are 200 these guys. And let's start by opening this view.openfoam file. There we go, it's loading. So one thing to note about this view.openfoam file is not all of your simulations will have it. You can easily create this file by creating a text document and saving it as view.openfoam. Make sure it doesn't have any like .txt at the end. It just has to be view.openfoam. So we'll close that, and it's a view.openfoam file. So we look for openfoam reader. Here it is, and we said okay. Then we hit apply. So here we'll see our domain. You can change the thing we're looking at from pressure to velocity. We can change it to surface with edges, and you'll see that our domain is this mesh here. So what we want to do is, let's try extracting the whole domain. The goal of this video is to learn how to extract the whole domain, how to extract selected points of your domain, and how to convert the extracts for all of the time steps into that data cube that we talked about. Let's first start off by clicking this guy. So this is opening up a vertical, it's called split horizontal axis. You can also do it for the bottom here. And we open up spreadsheet view. So the data in this spreadsheet view, these are all of the points here in this domain here. So the points are these like intersection points for these lines. Those are the points. You can see if I click on this guy, you see that it's displaying the point. And when it talks about a block is referencing this thing here. This is a block or a cell. Here you see cell data, so cell. And if you hit hover cells, there's information on the cell. Okay, let's reset the view. Your coordinates, X is to the right, Y is up, Z is out of the screen. Let's select some cells. So you see here, I hit select points on. The shortcut for that is D. and I selected these points. They're highlighted in pink. And if you go here and you click show only selected elements, so this is the cell data attribute. This is the point data attribute. You have the point itself. Z equals 0.5 is corresponding to points that are here highlighted in pink, and Z equals minus 0.5 is at the back, but they're not selected right now, so that's why you're not seeing them. P is for pressure, it's a scalar. U is a vector, that's the magnitude of the U vector. This denotes the block name. It's only showing internal mesh because here in mesh regions, only your internal mesh is shown. And your internal mesh is pretty much where the computations are being done. So that's your actual simulation. So let's go back to our default view and let's deselect all of these points. And you see here, I hit that trash can button, and let's deselect that. So when you hit that button, it's called the show only selected elements button. That only displays your selected elements. And if you turn it off, if you turn this off, it shows you all of the points, and you can reduce the precision or the number of decimal points after. With this button, you can also do other things like toggle the visibility of certain columns and even save this data for this particular time, which is 35 seconds. And let's save it in this folder. You can name it anything you want. Let's name it test. Hit OK. Let's do 4. And if you go here, post-processing, relearning, there is our test. And you'll see that this consists of almost 9,000 points. So we're going to reduce that down to like 2,000 points or 2,800 points. Let's delete this guy. And let's now select our point. Okay, so let's select our points here. So we'll hit this guy. Just L, no, not S. Yeah, we want this guy, D. Zoom in a little bit. And let's say somewhere around here. That's a good place to stop. So we're only interested in these points here. You can see that all of them together. We need to select this guy. All of them is around 2631 points. But actually we need to make sure that we're not selecting points at the z equals minus 0.5. So what we'll do is turn it around, and oh, you see here that is showing some highlighted points at the back. So let's deselect them. So you can do hit this toggle selection and hit select points on. You can also do D for shortcut. So if you hold shift and highlight over that, you see that it got deselected. And you see some of the points in the front got deselected as well. So we need to reselect those points only. So I'm gonna try and zoom in slowly. Also, some points at the front are not selected. So what we can do is make sure that only the front face is visible. Hit D and hit Control instead. And there we selected those around the circle. Next thing, let's hit D. Let's hit Control. There we go. Hit D again, hit Control. Likewise for here, hit D, hit Control. Hit Control. D, hit Control. And we're just trying to make sure that we got the points we're interested in. I think that's good. Okay, so now 2740 points. So we want to only get data for these points, not the rest. So we'll hit extractors, data, well, not extractors, filters, data. Sorry, it would have been mesh analysis. No, mesh data analysis and extract selection. When we hit apply, we'll see oh, we should have seen the background disappear, but for some reason, okay, there we go. So that is our selection. Oops. Let's hit delete there. Hit U. And you can see that's our selection. Now when we click that and only this layer is visible, extract selection 1, you see that this contains only those data points that you see in the screen and that there are 2,740 points. Now what we're going to do is extract this data. Now you could do download and then hit next frame and then hit download again and hit next frame, but obviously that's not a good use of your time. So instead what you need to do is extract this data. So we want to do extract data CSV, leave it at time step, frequency is 1. I believe frequency refers to extracting each folder if it's 1. This is your naming convention, so anything in this curly brackets changes, it gets updated with each time step. So if you have time step colon 06D in there, so it would be the first file is dataset underscore time step, which would be, let's say, like time step 35. It would be, no, sorry, time step 0. It would be 0, 0, 0, 0, 0, 0. So 6 zeros. If it's 1, it'd be 5 zeros and 1. So data set underscore 0, 0, 0, 0, 0, 1. So let's change this to match our the naming convention that's in my script right now, which would be just just time step in the curly bracket, and it would be extract. in the front here. Precision, we can do 5 or yeah, let's do 5. These are the things you can include them if you want. You can use scientific notation if you want. String delimiters for like stuff with words. It would be separated out with these quotes. And these other guys you can mess around with on your own time. So hit apply, and then you can hit this save extracts button. You can also do it here, save extracts. So hit here, save extracts. Frame stride 1. This is, if you hover over this, there we go. So if you wanted each frame, you'd like as in first frame, second frame, third frame, you do 1. 0 to 199 is basically all of the files in this path here. We need to also update this path. So that's the path we want. So hit OK. Hit apply, and if we hit OK, we'll see that there, all of our extracts are coming out. I believe they're done. Okay, great. Now that that step is done, we need to run our script. So I'm going to open up Python here. And so each of these CSV files corresponds to a time step. So extract 0 corresponds to this folder. Likewise, extract 1 corresponds to that folder. Or I believe it's at 35, so this corresponds to 35. Let's find that script that Okay, in this script, you need to update your path here, and you also, well, you don't need to update your path here. This is you like loading the file and making sure it's correct. This is you specifying the path where it's gonna get saved and where you're gonna also draw your CSV files from. You can see I've already updated it to be the correct path. Thing to note is that your forward slashes, these are forward slashes. They are normally backward slashes. So you need to change that, or you need to change the read option to be something else. I forgot what it was. In our simulation, we saw that the vortex shedding doesn't really start until like this time step, like 140-ish. So what I want to do is only grab the folder starting with 149, and at that point there will be 51. So this would be the start and this would be the end. And you can mess around with these numbers on your own. Here is that file naming convention that I talked about. So you can either change this, or you could either change The openfoam one over here where you did this guy, this naming convention. So either one of those you need to change. You choose one or the other. Converting to numpy arrays, then we create a dictionary to store it. Then we save it as a data cube. So this script handles the creation of the data cube. So let's hit Shift Enter. See, it's loading up on that ran, so that's good. This shows your current working directory. You hit Shift Enter again. It ran. And see here, everything's running. So it looks like things are good. So I'm gonna hit save here and close. Just leave it open. So we look in here. There's our data cube. You can name this to something else if you like. Would be here. You change that name there. I believe we named the last data cube to be data cube shortened V for version, so V main 9, so 0509. I believe that's everything I wanted to show you. We talked about extracting data for the entire domain, and we realized that we're only interested in the part that's doing stuff. So we instead extracted out these points here that are highlighted, and then we and then after we did that, we did a extractor data CSV on this dataset. You can see here extractor CSV. Then we hit apply or fix these stuff and then hit apply. And then we went to the script and we ran it. So I think you are good to go. That's about it.